Okay, so question 6. Logic gates. Yay! Hopefully nice, easy marks. Okay, logic gates are, I find, quite fun. It's like doing a Sudoku puzzle or something. But anyway, we have this expression, x equals a and b, or b and not c. And we have to draw the logic circuit. It must have 2 inputs, so if you go into A-level, you can have multi-input gates. And do not simplify the logic expression. So don't try and make this into something more efficient. That's not what they want. They want you to draw it out exactly as it is on there. Okay, so we get 3 inputs, A, B, C, and we'll get an output, X. I'm going to use the logically.ly / demo because it's quite a cool site. Just to do it, so I get A, B, and C. And I could label those if I wanted to with A, B, and C. And we're also going to have, at the end point, we're going to have X. Okay, and X is going to be my little light bulb here, so it's going to be on or off. Okay, so let's go here. Now, here we go. So we've got our brackets. Now, just like in any other system or maths, brackets come first. So like PEMDAS, BODMAS, whatever you want to call it in maths. We also have an order of operation for logic gates. So we should have nots, then ands, then ors. So if for some reason they don't have the brackets, you should apply your nots first, where possible. Obviously, if it's outside the brackets, it's going to be harder. We're going to have nots where we can, and then we're going to apply ands, and then we're going to apply our ors. So let's try and draw that. So A and B. So let's start with that first bracket. A and B. So it's going to look like so. A and B. Okay, and then we've got, in the other brackets, we've got B and not C. Okay, so I've got and and not, so I should do the not first. So let's do not C. Not C. Okay, and B and not C. So we need another and we're going to connect B and not C. And then finally, we're going to connect those 2 lines together with an OR to give us X. So we apply our OR gate, doom, doom, and then let's move X a bit closer. And so I believe that that is going to be the answer to that question. Again, it's one of these things you kind of just got to learn, you got to just go with and practice it. But remembering the different orders of operation can be helpful at times. Okay, and let's pop that onto my paper for the next question. Okay, so then we need to complete the truth table given the various logic. Okay, so well, first of all, I'm going to copy that question just so that for completion. And put that above my thing here. Okay, so then I want to go here and I want to do this table. So basically, I have got to make the table to go with the diagram that I've just made, or to go with the logic statement that was there as well. Now, what I would do is I would start by going into my diagram, and I would label the gates inside of it. Okay, now like I say, let's do nots, then ands, then ors where we can. So I'm going to call my not here, let's call this one, so A, B, C, D, and then A and B, let's call that E. Let's call this one F, and then this one, the output is going to be X anyway, so we don't need to worry about that. So we're going to need 1, 2, 3, 4, 5, 6, 7 columns on my table. And that's the whole point in the working space. So if you've got a table like this, really you should then, in the working space, draw in the new points that you've done. What did I say? I think I said 7? 7 by 9? Let's go by 7 by 9.